So everybody has their notes yet from yesterday. I got my new chair. And the whole reason I bought it was so that it would support my neck, and it doesn't. It like, it's too far, like I'd have to sit like this, plus I'm too tall for it. So now I have to figure out a way to return it and get some else. Well, that's great. All right. So we today are gonna do the distance formula. And I don't know if I told you yesterday, but it's the top row, it's the fifth one over. But I'm also gonna have you take out that sheet of notes that you have. Do you remember that chapter 1 notes that you have in your notebook? And I'm gonna have you copy that formula down in a second in there. And I'm gonna show you guys 2 different ways to do distance formula. One, you can do it on a graph and use Pythagorean Theorem, which we probably have heard of before. The other is actually using distance formula. And it's up to you which one you want. The only thing, if you use Pythagorean Theorem, you have to use graph paper. And I always have graph paper up here. Like there's a stack right here. So even on the test, I won't provide graph paper, but if you want to do it with Pythagorean Theorem, you would just grab graph paper and do it. So I'll show you both ways and then you decide which way you want to do it. Okay. So I want you guys to copy this and then I'll move it down and you'll copy the Pythagorean Theorem down. And if you'd rather look in your notes, I think that's probably the only thing. I'll put in your homework this weekend. I haven't gotten to that yet, so plan to take it home and try to put it in. Did everybody get this copied already? I move it down to Pythagorean Theorem. So if you do the distance formula, you don't have to use Pythagorean Theorem. If you use the graph paper, you use Pythagorean Theorem. So it just depends which one you choose to do today. Did I give you enough time? Okay, so let me see which way I show you first. Okay, we're gonna do the Pythagorean Theorem way first. Okay. And so what happens with this is you'd be given the 2 points and you would use graph paper, which I have up front. Okay. So what you would do is plot these 2 points. So you'd go -4, -6. All right. And then you'd go over 5, down 1. Okay. Once you have those 2, and I have rulers. If you would like to do straight lines, you certainly can. I'll take those out. But what you're gonna do is form a a triangle where you're gonna go across horizontally and down vertically. And those are the legs of your triangle. And then you're gonna connect this. Now, you also could have done this triangle. So it wouldn't matter which one you did, like this upper one or this lower one, you would get the same answer. Okay, so now what we do once we get that is we would count across how many squares we have. And like this would be 1 square. That's 1, okay? So we count here. You don't count, the reason I say that is some kids count these lines. You don't count the lines, you count the square. So across, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And this is being 1. And then I count up 1, 2, 3, 4, 5. All right. And I think of this as my right angle. And now what I've created here is a right triangle. And if I go back to that formula, I'll just kind of explain this a little bit. When you have a right triangle, the two sides that kind of border that right angle are called legs. And then the diagonal side is called the hypotenuse. Okay. And what we do with Pythagorean theorem is we call the two legs A and B, and it does not matter which one's A and which one's B. You can call either one A and either one B. But the C has to be across from that right angle. And we've labeled that as C. Then what Pythagorean theorem is A squared plus B squared equals C squared. And then we substitute in. Okay. So if I look down, what I'm looking for is this C. So I am going to write down A squared plus B squared equals C squared. A and B do not matter. So one of the legs you're going to let equal A, bless you, and one of them you're going to let equal B. So let's just say I let this be A and this one be B. So in for A, I put 9 squared. In for B, I put 5 squared. And that equals C squared, which is what we're trying to find. Okay. Now, 9 squared is 81. 5 squared is 25. Which you could have just punched that in. You could have just gone 9 squared plus 5 squared on your calculator. But once that you add these together, you're going to get 106. That is C squared. Do you guys know how to get rid of a square? Square root. Yes. So now we're going to take the square root. And what is the square root of 106? If you go to your calculator, on a graphing one, how you do it is you'd go second square root 106. So it's second squared, and then 106. And we are going to round to 2 decimal places. So we're going to write this as, what happens when you have a 9 here and there's a 5 or greater above it? You round that up. So think about that. What would 29 round up to? 30. Yes. So this would be 10.30. Okay. If anyone wants to come up and get a calculator, you can do that. They're up here as the regular ones. And then I have graphing ones in that drawer. So if you want to, you certainly can. Okay, so now let's go down to this one. And we'll graph this. So M is 2, 4. So I go over 2, up 1, 2, 3, 4. And I put in M. N is -3, -2. So I go -3, -2. That is my N. Okay. Now what I'm going to do is connect those and kind of form that right triangle. So you could connect these right away or do it after. But now what I want to do is I want to form that right triangle. So I want to go over this way and down this way until they meet. Okay? So here is what we have. When you count again, one square across, 1, 2, 3, 4, 5. And going up is 1, 2, 3, 4, 5, 6. So then we would write down a squared plus b squared equals c squared. Now, my c is across from this right angle. So this is c, and remember a and b don't matter. So we can say a equals and b equals. Okay, so a is 5, and I'm going to square that. B is 6, and I'm going to square that, and it equals c squared. Okay, now 5 squared is 25, 6 squared is 36, and it equals c squared. 25 plus 36 is 61. And then like we talked about, when you get to c squared, you take the square root. And so c is, we would go second square root 61, enter. And so this one would be 7.81. Now, as far as work goes on this, if you do it on the graph, okay, obviously I'd want to see this. And then I would ask that you could skip this step, do this step. If you punch this into your calculator, you could skip this step. So I'd want to see this, this, and this. Okay, so if you do it this way. How do you guys feel? Do you feel like you need another example of that, or is that okay? Everybody feel that okay is okay? All right, so now let's go to here. So now we're going to do the same type of problem, but we're going to do it with distance formula. And again, like we said, this is the distance formula. And this you learned back in Algebra 1, I would bet. So when you go to do this and you do your first point, the first coordinate of the first point is your x, and we call it x sub 1. So that means x of your first point. And then this is y with a 1. This one is x sub 2, and this is y 2. Okay. Now, when you look at the distance formula, honestly, it doesn't matter which way you subtract, but you have to be consistent. So I typically just follow this and I do this minus this for here. But just so you know, like if they were on a graph, okay, like -4, -6 is going to be over here somewhere. And 5, -1 is going to be here somewhere. You know, if the points are listed like that, it does not matter which way you subtract, but you have to be consistent. So the first one is subtracting your x's. So if you went this one minus that one, then make sure you go this one minus that. Just be consistent each time, okay? So what we have there is we are going to do for our x's, we are going to go 5. And this is where I see kids get mixed up on this. There's a couple places. When you go 5 minus a -4, okay, 5 minus a -4, kids will skip a negative sign and they'll just write 5 minus 4. Okay, it's the equation we have to subtract. So it's 5 minus a -4 squared. And then there's a plus sign. this. And then we're gonna subtract our y's. And with our y's, again, we're gonna go that same way. So we're gonna go -1 minus a -6. Quantity squared. Once you get that, and I want you to write that out. Once you get that, then we're just gonna simplify this. In math, if you have two negatives. It becomes a positive, right? So this is really 5 plus 4. What's 5 plus 4? 9, and we're gonna square that, okay? Here it's -1, and what happens here when you have two negatives? You change it to a plus. What's -1 plus 6? -5 or regular 5? -1 plus 6, isn't that 5 squared, right? Okay, then what we're gonna do, 9 squared is 81. 5 squared is 25. And then you add those together. And 81 plus 25 is 106. Then again, you'd go to your calculator and you take the square root of 106. Oops. Yeah, right. So would it be 10.30 again? Okay. Now, here is where I find kids do distance formula wrong. Because on the test, a lot of people get these wrong. Some kids don't write down the correct formula at the beginning, so they don't have a positive here. They don't have negatives here. So that's the first thing. Make sure you have the right formula. But the other place is a lot of times these numbers are going to be negative. So say that under there was -4 squared plus -3 squared, let's just say, okay? You could type this into your calculator, but on a calculator, do you guys know it, like if you took -4 squared, is it -16 or is it +16? It's positive. But if you went to your calculator and you went -4 squared plus -3 squared, it would give you -16 plus -9, and you'd get it wrong. Okay? When you put that in your calculator, if you want to, you can. Don't do the square root yet, but if you went parenthesis, -4 parenthesis, and you can do this on any calculator. It doesn't have to be graphing. And then you hit x squared plus parenthesis, -3 parenthesis, x squared, enter, then it gives you the positive. Okay, you have to remember in these, if you square a negative, it's positive. So let's do one more and then we'll see how you guys are doing. That's really all we're learning today. So if we go down to this, let's actually go down and do this, just because we didn't do that in the previous problem. So again, we're going to think of this to be x1, this to be y1, and then this is going to be x2, and this is going to be y2. Okay? When we go to put them in, we subtract and we go 8 minus a -5. 8 minus a -5 squared. Okay, and then we go -4 minus 6. -4 minus 6. Okay, now, if you look here, we have two negatives in a row, and what happens with two negatives? It's positive, and so 8 plus 5 is 13 squared. Here, what's -4 minus 6? -10. Plus. and this is negative 10 squared. Now, again, if you put that in your calculator, the positive you don't have to put in parentheses, but the negative you do. So I usually just do this in my head, but if you go 13 squared plus negative 10 squared, just put the negative 10 in parentheses. 13 squared is 169. A negative 10 squared is what? 100, a positive 100. And then this is going to be 269. And the square root of 269 is 16.4. So do you guys feel okay about how to do these? And you only have to do one of the ways. So you kind of choose. If you're going to use Pythagorean theorem, you're going to want to come up here and grab a piece of this wrap. So your assignment then for today is this. How many of you think you'll use graph paper? You'll just do the distance formula. But it's really up to you. It doesn't matter to me either way. And then check your answers as we go through to make sure you're doing it right. I have the page open. There are a few on here that have it rounded to 1 decimal point, but in this class, I always want it rounded to 2. So your answers will be a little bit different. Me?